Hello, and welcome to this video on using the discriminant to determine the nature of solutions of a quadratic equation. So in this video, I'm going to be describing what the discriminant of a quadratic equation is and how you can use that number, that discriminant, to say something about what kinds of solutions that quadratic equation will have, whether they be rational number solutions or irrational number solutions or complex number solutions that are not real, that have a non-zero imaginary part. So I'll begin by describing this discriminant. All right. So suppose we're given a quadratic equation in standard form. If you recall from prior videos, right, a quadratic equation in standard form had everything on one side, right, had a quadratic polynomial, ax squared plus bx plus c on one side, and then 0 on the other side of the equal sign. So remember that if you're given a quadratic equation in this particular form, in this standard form, then the solutions of that equation can be found using the quadratic formula. So the solutions are, x equals, and here's, I'm going to write the quadratic formula, again, as I had in the past video. It's in standard form. I identify the coefficients a, b, and c, and then use them in this formula here. It's the opposite of b, plus or minus, one with the plus, one with the minus. Then a radical, right, the square root, and inside that square root, b squared minus 4 times a times c, right, all inside the radical. And then everything I've just written is in the numerator. So the big fraction bar, big division bar here, and in the denominator 2 times a. Right, where this a, b, and c are again just the coefficients of the quadratic polynomial when it's in standard form, right? The ax squared plus bx plus c equals 0. Alright. So when you look at this formula, there's one thing about this formula that will help us determine the nature of the solutions of the equation. Are the solutions going to be irrational numbers or rational numbers? Are there going to be two solutions or one solution? Will the solution have an imaginary part to it, right? Will it be a complex number that's not real? And all of that can be determined by the radicand of the radical. All right, this expression right here. I'm going to put it in a circle or an oval. Right? I'll circle it. The b squared minus 4ac underneath the square root. That's going to help us determine the nature of the solutions. All right, it'll help us, discriminate which, among the solutions or among the possible types of solutions. So they call this radicand the b squared minus 4ac. This expression, this value, is called the discriminant. of the quadratic equation. And notice it had to be, in standard form, right? The only time you can use the quadratic formula is when the equation is in this form here, where everything's on one side, zeros on the other. So it's called the discriminant of the quadratic equation. Okay. Now how does this, right, how does this b squared minus 4ac, tell us about the nature of the solutions we're going to get? Let's, I'm going to keep the quadratic formula up here, and we'll talk about, what happens when b squared minus 4ac takes on certain values. All right. So 1. If b squared minus 4ac, if the value of the discriminant is a perfect square, right? Remember, perfect squares were, like, for example, 1, 4, 9, 16, right? 1 squared, 2 squared, 3 squared, 4 squared, and maybe even like a fraction that's squared, maybe 4/9, right? That's 2/3 squared, etc., right? And notice how they're all non-negative, right? Anytime you take a perfect square, remember, is a rational number squared, right? So you take any rational number and square it, it's going to be non-negative. So if b squared minus 4ac is a perfect square, right, some rational number squared, well, look at what's going to happen. I'd have, the opposite of b, plus or minus the square root of a perfect square. So that'll simplify, and we'd have the square root of a perfect square would just be a rational number. So I'm going to be assuming here that a, b, and c are all rational themselves. So I guess I probably should have put that earlier. All right, we're assuming here that little a, little b, and little c are rational numbers themselves. And if you're unfamiliar with what a rational number is, please look up a video on it. I'm not going to go into it. It's just a ratio of two integers. All right, and if you don't know what integers are, again, I'm not going to go into all that in depth. So if a, b, and c are all rational, and then b squared minus 4ac, this is also a perfect square. The square root of a perfect square will be another rational number, and then I'd have rational numbers all over the place. We would end up with, two rational number solutions, right? Negative b plus some rational over 2a, and negative b, minus some rational over 2a. So if b squared minus 4ac is a perfect square, then the equation has two rational solutions. Again, if we're assuming a, b, and c are rational themselves. Okay. Number 2. Right, that's so if b squared minus ac is a perfect square, we can say something about the solutions, what types of solutions we're going to get and how many. Well, what if b squared minus 4ac is not a perfect square, but still not negative, right? But still positive. So what if b squared minus 4ac is still positive, right? Let's stick with positive numbers, but not a perfect square. Is positive and not a perfect square. All right. So examples of that. positive and not a perfect square, I'm talking, 2, 3, 5, 6, 7, 8, etc. Right? And you could also think of fractions like 1/5, whatever, that are positive and not a perfect square, right? I can't think of a rational number to the second power that would give me any of these numbers here. Well, if that's the case, I put out a video a while back now. If you're taking the square root of a non-negative or a positive not perfect square, that number is going to be irrational. Okay, so I'd have negative b plus some irrational number over 2a, and negative b minus some irrational number over 2a. So we end up with two irrational solutions to the equation. Right? So if b squared minus 4ac is positive, but not a perfect square, then the equation has two irrational solutions. All right, case 3. So we've talked about basically the positive cases, right? If you're a perfect square, you're going to be positive. If b squared minus 4ac is positive but not a perfect square, right, then you have irrational solutions. Let's get into a couple. Now, there's only two other cases. There's only two other possible values that b squared minus 4ac could be. If b squared minus 4ac is equal to 0, well, then look at what happens here. We'd have negative b plus the square root of 0, but the square root of 0 is just 0. So you'd have negative b plus 0 divided by 2a. Well, adding 0 doesn't mean anything. So you'd have negative b over 2a as a solution. And then negative b minus 0, same thing, just negative b over 2a. You'd get just one solution that's repeated. They call it a repeated solution. But the equation has only one real solution. It would be this, whatever negative b over 2a is. Alright, so then the equation has one, and again, if we're assuming a, b, and c are rational, it would be one rational solution, but I'll just say one real solution. And this would be called, because you're seeing it twice, negative b plus 0 over 2a and negative b minus 0 over 2a, this is going to be called a repeated solution or a repeated root. Okay. Then the final case, right? We've talked about when the value of the discriminant is positive in a perfect square, positive not a perfect square, when it's equal to 0. The only other case we haven't mentioned is when it's negative, right? So case 4, if the discriminant is negative, right? If b squared minus 4 times a times c is negative or less than 0. Think about that. I'd have negative b plus the square root of a negative number, or negative b minus the square root of a negative number. And hopefully you recall that when you see the square root of a negative, this off to the side here, I've had this property up before. So suppose n is a non-negative number here. This is the square root of the opposite of n, right? So the square root of a negative number. Remember, these square roots of negative numbers are actually, these pure imaginary numbers. they can be written as a real number, the square root of positive n times that I, right, where I was the principal square root of -1, right? If you were to square I, it would be -1. Okay. So if b squared minus 4ac, if the discriminant is negative, then we have the square root of a negative here, which is one of these pure imaginary numbers. So we have a real number plus a pure imaginary. That makes, you know, the form of any complex number with an imaginary part. Now remember, every number is complex, right? Even, you know, when I said I had two rational solutions in case 1, that's two, you know, rational numbers are complex, irrational numbers are complex, you know, real numbers are complex. Everything's complex, but what we're going to be seeing here are complex numbers that are not real, right? That are not specifically real, not purely real, but they have this imaginary part to them as well, right? This number with the I attached. So if b squared minus 4ac is negative, then the equation will have 2, right? Again, one with the plus, one with the minus. 2 complex solutions that are not real. All right. Again, everything's complex, but these specifically will have an imaginary part to them, an imaginary number involved in the writing. Okay. So after having gone through these cases, let's do some examples. All right, that's the rest of this video. I have a few examples here for you where we're going to be taking a look at a quadratic equation asked to determine its discriminant and then use the discriminant to say what kinds of solutions the equation will have without actually solving it. Okay, so here I'm asked to, and for the rest of the exercises in this video, the following directions. Use the value of the discriminant to determine whether the quadratic equation has 2 rational solutions, 2 irrational solutions, 1 repeated real solution, or 2 complex solutions that are not real. Alright, so here I'm given in this example, 2z squared plus 5z plus 4 equals 0. This is the way I need this to start, right? In order to use the discriminant, right, it's just like the quadratic formula, right? You know, the discriminant is part of the quadratic formula, right? It's the radical, the radicand of the radical symbol. So you can't use the discriminant whenever you can't use the quadratic formula. And the only time you can use the quadratic formula is when it's in this form, right? This is in that standard form where every single term is on one side with the variables and the constants, and then you have 0 on the other. You have your quadratic polynomial on one side, 0 on the other. So that means we can use the discriminant. All right. So first I'll identify the coefficients, right? Remember the lowercase a is the coefficient of the square term, z squared, that'd be positive 2. Lowercase b is the coefficient of z to the first powered term, which is positive 5. And the lowercase c is the constant coefficient, the coefficient without a variable attached. That's this positive 4. All right. Now for the discriminant. Remember, the discriminant is just that expression underneath the square root symbol, the radicand, of the quadratic formula. And that was the b squared minus 4ac. Alright, so let's see what that's equal to for this particular equation. We have, b is 5, so 5 squared minus 4 times A, which is 2, times C, which is 4. 5 squared is 25. And we have negative 4 times 2 is negative 8. And then negative 8 times 4 would be negative 32. Alright, and then 25 minus 32 is negative 7. So which of those four cases do I have here? Right, the value of b squared minus 4ac is a negative number. And that was case 4. Right, if you go back to, I'll bring the page back up. That was this case here. So in that case, the equation is going to have two complex solutions that are not real, right? You're going to end up with the square roots of negative numbers in each solution. So each solution is going to have an imaginary part to it, right, and not be real. So the equation has two complex solutions that are not real. And there we go. And that's all I am asked to do. Right? Find the value of the discriminant, negative 7, and use it to state what kinds of solutions the equation will have. Two complex solutions that are not real. And that's all. That's all I'm asked to do. Okay. I'll just have a couple more. All right. My next example, I have another quadratic equation. Right. 4y squared plus 12y equals negative 9. Now the question should be, if I'm asked to find the value of the discriminant, the question should be, can I? Right? Can I use the discriminant yet? And that's the same as could I use the quadratic formula to solve this? And the answer this time is no. This is not in that standard form. Right? It's not in that form where you have the quadratic polynomial on one side and 0 on the other. So I'm going to put it in that form first. Very simple to do here. All I would need to do is make this side 0, just adding 9 to both sides. And now I have on the left, in descending order, 4y squared plus the 12y, then plus 9 equals 0. Now I am in standard form for a quadratic equation. I could use the quadratic formula to solve it, but again, I'm not asked to solve it here. I'm just asked to find the value of this discriminant. Alright, so what is that again? Right, so the discriminant, remember, is this value here. That b squared minus 4 times a times c, right, that expression underneath the radical in the quadratic formula. So I need to know what the a, b, and c are. So I'll identify those over here. Remember, the value of a is the coefficient of the square term. That'd be positive 4. The value of the b is the coefficient of the first powered term. That would be the positive 12. And the value of c is the coefficient of the constant term, just the positive 9. Alright, so I substitute those into my expression for the discriminant. B squared, right, so the number 12 squared minus 4 times A times C. 12 squared is 144. Then, minus 4 times 4 is 16, and 16 times 9 is 144 again. I mean 90 plus 54. So I'm getting 144 minus 144. So the value of the discriminant is 0. And let's see, which case was that? Right, that was case 3 that I wrote up on an earlier page. Right, this one here. If the discriminant is 0, then the equation will have one real solution. Right, one repeated real solution. Right, basically the same number twice, because you'll be adding 0 and subtracting 0 from that negative b in the numerator of the quadratic formula. So the equation will have just one repeated real solution. But only one solution. And that's it. Again, that's all I'm asked to do for this these exercises, these examples. All right, I've got one last one. Right, I just wanted to show you this one here so that you know, hey, it's got to be in standard form first. All right, before you can use the discriminant, before you can use the quadratic formula to solve it. All right, so my last example is nicer for us, as it is already in that standard form that ax squared plus bx plus c equals 0. So I've got 2x squared minus 4x plus 1 equals 0. Let me identify those coefficients. Right, the value of a is the positive 2. The value of b is negative 4. Don't forget the negative, because that's technically plus negative 4x. So the coefficient's negative 4. And the value of c is, positive 1. All right. Then the discriminant, I'll write it again, is the value of that expression underneath the radical in the quadratic formula, that b squared minus 4 times a times c. So for this particular equation, the value of the discriminant is, b squared, or, negative 4 to the second power. That'll end up being positive, right? Negative times negative. Then we have minus 4 times a, right, times 2, times c, right, times 1. All right, so negative 4 to the second power, negative 4 times negative 4, positive 16. And then, minus 4 times 2 times 1 is 8. So I have the value of the discriminant is 8. So this is a positive number, right? Positive 8. And, if it's positive, you should then ask yourself, is it a perfect square or not a perfect square? Because that'll determine whether or not you have rational or irrational solutions to the equation. Well, remember the perfect squares, where 1 is 1 squared, 4 is 2 squared, 9 is 3 squared. 8 is not one of those, right? 8's not 1, 4, 9, and then 9's too big, right? So I'm not going to go any further than that. So it's positive, and it's also not a perfect square. And let's see, which case was that? That was case 2 that I wrote in my previous pages, right? If the discriminant is positive and not a perfect square, there's 8, right? Then your equation is going to have 2 irrational number solutions. Okay, and that's it. That was all I was asked to do. Right. Find the value of the discriminant if I could, if it was in standard form, which it was, and then use the value of that discriminant to then say something about the nature of the solutions of the equation, what kinds of solutions it has. Okay, so I think that's enough. I didn't cover that first case, but again, if the discriminant ends up positive and is a perfect square like 9 or 16, then you'd have two rational solutions, right? So you might come across examples like that as well. All right. And as I like to say at the end of these videos, do the best you can to learn material on your own before you go looking for help. I find that people that take the time and the effort to learn something on their own tend to remember that material for longer and also remember it better and are more proud of themselves. So that's a plus, right? You got more confidence, more self-esteem when it comes to the subject. So of course, read the material, right? Read through the author's examples. Perhaps even try to work out the solutions to an author's examples before you see how the author did it. And then compare your work with the author's and see if you can fix things there, learn from some mistakes there. Obviously, do tons of exercises, practice problems. It's the only way to get better. And check solutions to those, if they're made available to you. See how you're doing, check your progress. And don't give up so easily on a problem. Don't give up after the first attempt or two. Very often, there are several approaches that'll work for any particular math problem. So if after several attempts at a problem you're still having trouble, then I would suggest you go back and read the material again, maybe even a third time, more slowly, more deliberately. Take good notes, because if you've been working on some problems, as you should, then you probably have a better idea as to what the author wants from you, right? What the author expects of you in that section. So then when you go back and read the material again, or that third time, you'll know better what to look out for. You'll know more about what's important to see in that section, and perhaps even things will pop out at you that didn't the first time through, and it'll make things make working on the problems that much easier. But if after that, if after several read-throughs of the material and several attempts at problems you're still not getting it, still having trouble, it's not a sign of weakness whatsoever to go out looking for help. That is what other people are there for, to help you. So ask a teacher, a tutor, a friend, someone in your class who you know knows the material well and is willing to help. Look for supplemental materials online. There's loads of that out there. Look for videos online. There's tons of those too. Videos like this one, or other ones out there that are better than this one. I assure you they're out there and they're easy to find. But just keep at it. Stay persistent. Keep practicing. Don't give up. And I think above all, and maybe the hardest thing for most people, is to stay positive about the subject. Try to have fun with it and believe in yourself and your ability to work through struggles and failures and mistakes. Because it's in those moments of struggle and failure that you can learn the most, and learn the most deeply. As if you actually persevere and work through and to fix your mistakes during times of struggle, you're going to remember that material far better and for far longer than the average person who would, breeze through the material if they get it right the first time and breeze through it and don't give it a second thought later. People like that, they'll typically forget the material right after the test. They'll forget it a week later, a month later. Whereas if you struggled and you have this emotional attachment to the material and you work through and persevere and fix it, when emotions are attached, when struggle's attached, learning is deeper. You'll keep that far longer than the person who breezed through. Okay, so stay persistent, keep practicing, stay positive, and don't give up. And I just know you'll get it. And thank you very much for watching.